Hi everyone. I hope everyone is having a great day and a great day. So today's problem statement is foldable binary tree. What is a foldable binary tree? Let's see. You are given a binary tree which looks like this 7 with the left node as 8, right node as 9 and then 10 and 11. Okay, 11. Now if I create a mirror image like there is two nodes and one root node and there are two more nodes. So if I overlap them, if I fold them this over this, then it will look like this 7, 9, 11 and 8 over 9 and 10 over 11, right? So it is foldable. But if the problem statement give us a binary tree which look like this 5, 10, 12, 9, 3. So if I do the same thing on it and try to fold it, then what will happen? 5, 12, 3, 10 will overlap with 12, but 9 will go here. So it is not foldable. So this is given in the problem statement that the tree, binary tree that they will give us that can be foldable or not foldable. So a tree can be foldable if left and right subtree of the tree are structure-wise mirror image of each other. Structure-wise mirror image. An empty binary tree is considered as foldable. If we are given the binary tree as null, there is nothing, then it is also considered as a foldable binary tree. So A and B are foldable. That we can see that 10 has two children, 7 and 15, and 9 and 11. So if I try to fold it, 7 will overlap over 15 and 9 on 11. Similarly, this is also foldable. But in C, if I try to fold it, then 7 will overlap over 15, but 5 won't overlap over 11. And in this case, because of 15 has only one child, 9 will not be overlap over any child. So it is also unfoldable. So we need to return yes or no for the required binary tree. Okay, so how can we do this? What is the approach? What we can observe here? What is the difference in both of these trees that makes one a foldable and another one not foldable? What is the difference? Let's observe carefully. So a null binary tree is foldable. So we can write in our code that if the given root is equal to null, then yes, then return true that a null binary tree is a foldable binary tree. Return true. But what if there is a binary tree? So then we check if the given binary tree, like there is a value, the root is not null, this is our root, then we will check for its left child and right child. We will check that left child is null or not, or right child is null or not. If it is, if root dot left or root dot right both are null, then also it is a foldable binary tree because 5 will overlap on itself, right? So this is all the second statement that if root dot left, I will provide the code of Python, Java and C++. I will explain three of them later. So root dot left if it is equal to null. Now I am writing in Java. And root dot right is also null. So we see that if this is our case, then we will return true, right? If this is the case, then we will return true. So far we have written two cases. One this for when we have only single root, and one for this when the root is null. Both are returning true. So in which condition we return false? Think about it. Which is the condition when we will return false? So this was the given binary tree. If this is not, if we are given with something like this 5, 10 and a null, if this is a null, so if I try to overlap it to fold it, then null is nothing. So it will basically there this is given to us. So we should return false, that it is not foldable. So how can we find it? How can we find this? It is very simple. We can write that root dot left is equal to null, or root dot right is equal to null. If this condition, first the code will check this condition, right? and this is true, then it will return. But for this case, this is not true. There is a root. So root is not null. So it will check for the second condition, that its left and right are null. But they are not null. This is null, left, but right is not null, and there we are using AND, so it won't get executed. So it will come on third statement and it will see that okay, left is null but right is not null. So one statement is true, so we will return false, that it is not foldable because there is a null in left child but there is not a null in right child, because we have checked for both of them and it doesn't get executed. So we come here and return false because one of these conditions return true for this. So we return false, right? Now this is one condition. But if we are given with 5 and then either 10, 11, 7, 15, 3, then how we will check here? How can we check here? So similarly, we will draw a line and see that 10 can overlap on 11, but 7 will not overlap on 15, because when we try to overlap it, 10 will overlap over 11, but 7 will look like this, and this is not foldable. So the condition for this should be the root dot left root dot left is a present, right? It is present. There is something. It is not equal to null. And if it's the case, then there should be something present here to handle this, right? So there should be something present here to balance 7. So what was this? Yeah, 11 and 15. So there should be something where here there should have something. So this should not be null. This should not be null. So if it is not null, then root dot left root dot right means 11 dot right should not be equal to null. If root dot left is not equal to null, then root dot right should also be not equal to null. And same for this case, when root dot left dot right is not null, then root dot left dot root dot right dot left should also be not null. They should be either both of them should be null or none of them should be null. So let's see the code. I recommend you to write the code by yourself. Now let's see what we have done here. So this is a C++ code. In this code, it is given, this is the given statement, is foldable. I write the first statement as if the given tree is nothing. If there is only null, then return true. Otherwise, call for another function in which I pass the subtrees of the given tree. Means the given tree is 5, 10, 11, 9 and 8. So if it is not null, then I have called for 10 and 10. Root dot left and root dot right. So in DFS, what I am doing, I am checking A is equal to null and B is equal to null. If there is no left and no right, then return true, because single 5 is also foldable. Or if this is not the case, then check if A is null or B is null. If there is only 10 left side but no right side, then return false. Otherwise, do the same thing for this 10, do the same thing for 9 and n, and the same thing for this null and 8. So if this is balanced, how we can check that? I will call for recursively call for the same function, this DFS same function 2 times. For A dot left, this is A, this is B, A and B. So A dot left, I call for A dot left but B dot right. So A dot left and B dot right. So it is similar to root dot left and root dot right, because root is 5 and I have called for its left subtree and right subtree, and I am recursively calling 9 and n by calling A dot left and B dot right. Okay, B dot right, we'll check for them and then check for these, and If all of them satisfy the condition, then return true, otherwise return false. Okay, I think the code is pretty simple. Now let's just run it. There are a total of 316 cases and all of them are passed. Let's see the Java code. So in Java, everything is same. First, the first statement that I've said, that if there is no node, if the binary tree is completely empty, then return true. If there is one node, then call for DFS function. And in this DFS function, return true if the left subtree and right subtree are null, and return false if there is left but no right. And then recursively call for DFS a dot left and b dot right, and DFS a dot right and b dot left. Why a dot left and b dot right? Because we want a mirror image. We want a dot left for b dot right. We want a dot right for b dot left. So this is also working. And similarly for Python solution, everything is same. If there is no root, if the given binary tree is completely empty, then return true. And if there is a single node present, then call for DFS. And DFS will check that left of given root is present and right of given root is present. If it is, return true. If not, then check for either left is present and right is not present, then return false. If this is not the case, then check for the mirror images. Check for a dot left, we want a b dot right for a dot left, and we want a b dot left for an a dot right. So this is also working. All these codes are present in the comment section. Thank you so much for watching, and I will see you in the next one. Thank you.